interfaces. All that information gets populated, including what platform you're running on. So you can use those attributes in the node attribute dictionary to change your code base paths depending upon what's in there. So we need to take a different path if we're running on Ubuntu or Debian versus Red Hat. Those are the keys we use to do our switches or conditionals. So recipes are compiled from the DSL to a different representation, a Ruby representation. Hey, and then we execute the recipe. So what does this look like? So we're going to git clone our repository again from GitHub. Within that repository, there's a scripts directory that we can use to one script to install Chef. So we're installing Chef right now on the machine. And actually, the script does a little more than that. It actually does a full system update. So it's actually grabbing a whole bunch of packages that are unrelated to Chef, just because we're doing an update. So now we're going to run Chef solo. So we'll look at the command line in detail in a moment. We run it as root, so we have the sudo. It generates all sorts of output as it's running, and these things all these logs get shoved into var log messages, var log chef stuff. And you'll see we're installing Python and then Python packages and Apache and mod WSGI. Get this output. Now we're creating the virtual environment. Pip is running. Pip is running here, grabbing all those packages. Now we're compiling code again. Our fingers crossed. And that's the full website. So that was taking a completely blank machine, installing all the packages we needed, including Postgres, running our code under mod WSGI, modifying the Apache configuration to run mod WSGI against our code base, and then it actually ran a fixture to pre-populate some data in the database using our object relational mapper. And that was running a little faster than real time, but that was taking a completely generic Ubuntu machine and running our application on it in a few minutes. That's pretty powerful, I think. So let's look at what we did there. So sudo chef solo -c is a configuration file, so we're going to pass it solo.rb, which is in our repository as well. Then we're going to pass it another file, which is called standalone JSON. So the contents of solo RB is this is the most minimal chef solo configuration possible, which is just a cookbook path variable that points to where our cookbooks live. And in this case, our cookbooks live sort of parallel to us in the same repository, where this file lives. So that's what this little bit of Python or Ruby code is doing here. Standalone.json. JSON is one of the formats the configurations can be in. So here we're setting a few attributes on a roster key that we're using. So load default data is true. That's the thing that loaded the fixture, took the fixture file and pre-populated our database. That's an optional thing you'll see in the code. We have to set a Postgres super user password. There's issues, of course, around storing authentication tokens in flat text files and source code repositories. This is the simplest way to do it. There are ways of encrypting these things within Chef so you don't have stuff just laying around in everyone's repositories. But then this is kind of the important bit here is run list. So the run list specifies a set of recipes that we want executed on this machine. That this is the set of configurations we want to apply. So here we're talking about two different recipes. One is roster database, and the other one is called roster app server. So this is the app server one. So this is the DSL, again, the Chef DSL, including a recipe called Apache 2 and another one called Apache 2 mod WSGI. Apache 2 is a standard cookbook from OpsCode, and it comes with mod WSGI. We want to include Python. So by including these things, these packages that are the packages that distro level packages that these depend upon will be installed as a side effect of including them. So just by including these now, Apache 2 will be installed. apt-get Apache. This is a little bit of Ruby code setting up some variables. So the deployment directory, and then where the virtual environment is going to live on disk. This is an Apache site resource. So Apache by default, when it installs a default, actually named default website. It's the one that's basically hello world. Yeah, Apache is installed and running. We need to disable it, and depending upon which kind of machine you're running on, sometimes it's named default, sometimes it's named 000 default, depending upon symlinks and how the people know Apache sites and sites and disabled or sites available stuff. So we want to turn the default off. We want to make sure it's off. We install a few packages. We want libpqdev, which I mentioned earlier is the Python or the Postgres client library. The virtual environment we looked at earlier, specifying the interpreter. And there's a few other options you can specify here if you need to, but pretty minimal. We're doing, again, the same pip install. So this is going to get us a requirements file. And the requirements file, again, this resource here that we're running under execute, because of the way pip works, is effectively idempotent, that if we run this again, pip won't download it and reinstall these packages if they're already there in the versions we requested. We're going to run a couple of Django admin level commands. So there's, within Django, when you create an app, it creates a manage.py file in your repository for you that allows you to synchronize the database schema with the schema in your code, or if you're doing migrations with South or something like that, you can do the migrations there. We use it for a couple different things. So we want to invoke it with syncdb, which will make the schema of the database match the schema of our models objects in the code. And then we're going to run collect static, which again is going to reach into all of the Django applications we have in our project and find all the static resources, the CSS files and all that stuff, and shove them into a directory that Apache is going to use to serve those for us instead of us serving them directly. Apache will do it much more efficiently. And then here we have this execute, Python exec, load data. This is loading the fixture data into the database on an app named roster, and the data we're on a load is called sum initial data. And you'll see we're using an only if operation here, only if attribute of the resource that says only do this if the roster app server load default data hash value returns true. If this doesn't, then this code won't get executed. So you can do this only if, not if. There's some conditionals you can apply there. So that's the thing that loaded our default data for us. So this is the database recipe. Again, we're installing Postgres client, Postgres server, because in this case we're running our Apache and our web server and the database all on the same machine. Obviously, as followed to Fred's talk earlier, that's not normal configuration for anything so big. We're doing a little bit of fancy footwork here to get a Ruby gem installed that we need called PG that's used by another cookbook called database. That's an ops code, high-level database idea, an abstraction of database resources that works on MySQL and Postgres and things like that. We then create a little hash of connection info for the database, where it's running, what the port number is, what username. Again, reaching into the node hash to get the super user database password. And then we're just creating 3 resources, or stating the 3 resources we need. One is that we want a Postgres database named roster, and I want you to create it if it doesn't exist. We specify the connection info up here, so we're just reusing this data here. We want to create a user named roster on that database with this password. And the database name that it should be given full access to from a permission standpoint granting is named roster. Specify the provider, which is a Postgres user provider as opposed to the MySQL user provider. Again, create the default action is create. Then we want to modify, we're going to put another one of these user resources in. We want the user's action to be, we want him to grant full privileges to the database. This is sort of a belt and suspenders approach, making sure we have full control of that database. So that's kind of it. So this, I think, the couple files are much clearer, and both in readability, and there could certainly be some refactoring, about the intent of the state of the system that we need for our application deployment. There's a whole lot more. So once you start going down this path, you can do things like parametric configurations or environments in the Chef world, where we need to run our code in a development environment. Each developer has their own full deployment of the system, their own copy of the database, their own web server, all these pieces. We need to be able to run in a staging environment or some QA environment, and we need to be able to run in production. And each of those have parametric variances, right? In production, we want to make sure we're talking to the right database, and we, different IP addresses, different credentials, and we want to run on different types of machines, possibly if we're talking about cloud provider information. There are cookbooks and Chef code bookends for AWS and EC2 and other cloud providers to spin up machines and manipulate load balancer configurations. And we need to have those different. We don't want to do any cloud stuff when we're running on the development environment because that's all on our laptop or on our desktop program. So that's very powerful. Now I have all my configurations across all my different deployments the same except for a few small tweaks on what databases I'm talking to and load balancers and stuff. There's another level of recipes that are called roles that are effectively a collection of recipes that should be applied to particular types of machines. So if I have a front-end web server, I may want to be running Apache 2 and Memcache on every one of those machines. So it allows me to write those recipes and then combine them. I may have other machines where it's just a database instance, or I may have machines that are Memcache instances. I may have other machines that are like MapReduce kind of slave machines. The next little thing about this is test-driven infrastructure. So because our configuration is just source, if I'm clever, I can actually do test-driven development on my infrastructure, which is a little mind-bending to think about what that means. But now I can write tests to validate my configuration and write the test before I actually have that configuration and known state of the machine. And then the next level of this is bootstrapping instances in the cloud. So Amazon EC2, for instance, has a, when you spin up an EC2 instance, you can provide something called user data, which is just a text block. Most Linux distros will interpret that as a shell script if it starts with a shebang. So you can create a little bit of code that you can pass to all of your EC2 instances when you spin them up, or put into the auto scaling configuration. That will automatically install Chef, download your code from GitHub, say, with some stored credentials for a limited permissions account that is read-only, say, on your repo. Download the code, run whatever recipes that you specified for it. So, hey, you're a web server, or you're a database, or you're Memcache. And the machine just comes up and will register itself with other services that are needed to connect it into your environment. And now you're done. I mean, that's like the best of all worlds. You can configure the monitoring, the remote logging, centralized logging capabilities, all those sorts of things. So it's very powerful. So the next place to look would be Chef Server, and Knife. Knife is the command line tool that allows you to talk to the Chef server to manipulate its configuration. The configurations associated with your machines. It does a lot of different things. There's lots of plugins, including like EC2 configurations and things like that, beyond just manipulating Chef itself. And it also will work with the GitHub repositories for the cookbooks. So you can get effectively a vendor branch of one of the cookbooks. You can check it out from the GitHub repo down into your local repo, and it'll automatically do it on a vendor branch for you, so you can pull down additional code in the future. Kind of stuff you can do with Git submodules too, but you have to be a little more sensitive about how you do it. So that's where I want to wrap up. If you have any questions, my email address, Twitter, the code from today is up in my GitHub repository. For more info, the Ops Code Wiki is really useful. That's why I don't have a tutorial about Chef. There's lots of good documentation out there around Chef. There's fast start guides, how to bootstrap EC2 instances, as I mentioned. If you're interested in the test-driven infrastructure, O'Reilly has a nice book on that. Came out last year, earlier this year. That's very useful. So I'm happy to, I feel like I've been talking for the last 45 minutes. I only have some questions. Fred.
Can you talk a little bit more about test-driven infrastructure? You touched on it a little bit, but I know when you're doing test-driven development, you have this very clear separation between things like unit tests versus integration tests. So you mentioned testing configuration, but what other sorts of things can you actually test with the TDI?
So you do a couple things. There are the equivalent of the unit tests are validating that a resource configuration is in the state that it should be in. And you can do that via a direct, like, Postgres configuration. I'm going to grep for some string within the configuration file. Or from the integration level. The Postgres configuration says that on TCP port 5432, I can connect with an MD5. I can validate that pretty easily. Can I connect with the Postgres client on an MD5? And then you kind of work all the way up to like smoke tests, the high-level integration tests of, okay, if I run these resources, or configure these resources on this node, can I now do an HTTP request on port 80 for some URL on that and validate that I get back something sensible? I don't get a 500. you got 200, maybe some of the HTML in there is what's appropriate, from the integration level. So the notion of unit test is a little fuzzier. We don't talk about mocking and stuff in that space, at least that I'm familiar with. So the people who wrote the O'Reilly book do some pretty fancy stuff with spinning up an EC2 instance and then running one of the Linux virtual machine sorts of things on top of it to quickly spin up sandboxes that you can run the chef recipes in without spinning up an EC2 instance. So you can spin up a deployment node in a millisecond, run the resource on it, run the test against it, and then destroy it.
So like continuous integration with infrastructure.
Yeah, which is this guy.
Cool.
Yeah.
So with all the operating system packages installation,
Mm-hmm.
it seems like that's a big external dependency. You're going to have a limited
Yeah.
shelf life. Because
Well, so there's a couple things there. When we tend to do this stuff, we tend to pick the LTS versions of like Ubuntu. That's going to be, I think, server and desktop are both support for 5 years now. In the web world, that's forever. So that limits my dependencies a bit. I'm not going to be changing this every 6 months, unless there's some new magic I need in the distro that'll force me to do an upgrade. So that's one piece of it. Does that help?
yeah, it does. And then the second question is very related. It's like, let's say I run a heterogeneous environment. Some of my servers are Red Hat.
God help me.
All right. As a matter of coding style in Chef, or do you just put if-defs around that sort of thing, or do you have multiple recipes for each?
So I glossed over this. There's a couple different levels of that. One is the providers under Chef are the things that know how to affect the resource configuration that you want. So when we said package libtqdev, that eventually gets dispatched internally in Chef to a provider. When we're running on Ubuntu, that provider knows how to use apt-get. When we're running on Fedora, it knows to use Yum. So you can do that for the package level stuff and a lot of the built-ins. What those are doing internally is they're keying off of that node hash. So I think that's the key platform, and that will be Ubuntu, Fedora, Scientific, or whatever. So you can write conditionals, and I mean, in the Linux world, it's pretty much Ubuntu, or it's Debian or Fedora. I mean, those are the only ones people really care about. Or OS 10, and you can, the typical way to do it is you write a switch statement where the default case is fail. I don't know this system, I've never seen this before, we're going to fail, throw up our hands. So that's one way to at least protect yourself, to put the exception in of, I don't know what this is, I'm going to say no. So, but yeah, so you end up having some conditionals there, but the hope is you can write the rest of your code in such a generic way that the number of things that are platform dependent are very, very limited scope. And they're only handled in a couple files, and everybody else can just say, package, libtqdev. In the same way, like Postgres versus MySQL versus Oracle, they're separate providers that know how to create users in those spaces. And that's all reusable code. Do you have a question, Andy?
Yeah, so in your initial walkthrough where you're doing things manually, you mentioned having to call up and hand modify like text files, configuration files. And I didn't see anything that spoke to that in the example. Is that something that's covered by the system-specific providers?
So those are primarily templates. So let me show you one of them. Oh, I did skip this. I apologize. This is horrible. So there's this little resource hidden in here called Web App. And this comes from the Apache cookbook. And Web App is going to be named roster. And the only thing in this case I have to pass in is a template file, which is in our source code repository. It's called rosterapache.com. So let me go and show that to you. You don't know how painful this is. So this is our chef repo in our GitHub repository. In our cookbooks, roster, templates, default. So default, we just went into a directory called default. There's ways of naming your directories in the templates and the other files, assets, to help specify or hint at what platform certain files should be used on. So this is the template file for deploying our mod.wsg Django instance. And you can see here we're saying there's a WSG script alias. This is a string to be interpolated in the template, which is specifying the deployment directory path. And then this is the wsg.py file in there that Apache actually needs, mod.wsg needs. Process group and WSG daemon stuff are pieces that we need to spin this up in an Apache daemon subprocess, as opposed to running it within Apache itself. We're specifying a Python path, again, doing a little bit of string interpolation. We're doing a directory string interpolation now. This is where my this is where my code lives. Create some aliases for media and static assets. And then this is where our static content is being served from by Apache. So we ran the collect static command against manage.py, populated the static directory on disk at runtime when the recipe executed. You grab the latest copies of all the static files and shove them in there. Now Apache is going to serve those for us. Same thing's happening for media here. So this is how we avoid manually editing the text files. We, in many cases, manually do the file the first time to get the system working, to get the state we need, and then take that, move it into a template, and then parameterize the pieces that need to change.
So it's not doing set and awk and parsing all that stuff?
No, it's not. It's actually just smashing this file in.
Okay.
And using Chef Server and stuff, it has a pretty sophisticated mechanism to prevent copying the same file down from the server to the client every time Chef runs. It does some pretty fancy caching stuff. But no, it just smashes the file in place. And that way, it's idempotent, because if I run it again, there's no doubt that the right file is in place. Because what it does is when it runs again, it generates this file, compares it with the hash of the file that's there in etc, Postgres, blah, blah, blah. You're different? Okay, now you're getting this. Or if the permissions have changed, because I changed the recipe, now I change the file should be owned by this user, and it should have these group level permissions. If those aren't the right thing, it'll go modify them. Yeah, Fred?
It might be kind of an asinine question, but I was thinking, if you're managing deployments of a very large number of machines, maybe one Chef server doesn't cut it. Is there a Chef recipe or a Chef resource for Chef servers?
Doing your Chef and your Chef?
So you could Chef servers?
Yeah, Inception and all that. Yeah, there are actually Chef cookbooks for Chef itself to deploy the server, and Couch and RabbitMQ and all the other things that have to happen. So yes, there are ways to automate that. Yes?
I don't know, I do a lot of this stuff, but I do it just with Fabric. I just like script it with Fabric, and I don't know, I feel like maybe this would be that useful for me, because a lot of times it's all custom to the environment. So does Chef have, like, is there an advantage of using a system like Chef when a lot of the times there probably it's not going to be like a pre-built like a cookbook for it?
Yes and no.
Yes and no?
Fabric's great. It's a great tool to get the job done. There's a large community in the Fabric world. There's a large community in the Chef world. So you can borrow a lot of pieces of common code and not have to rewrite all that stuff yourself. So, but again, Fabric is a fine solution. So if it's getting the job done, I wouldn't say change it. Be aware of this though, just so you can see what the differences are. I tend not to be very religious about these kinds of things.
I was just curious because, like, I mean, with Fabric, a lot of times it's almost more low level. You're not specifying the configurations.
Well, that's one of the arguments about a DSL that's declarative.
Yeah.
That this is the state I want things in. I don't want to be mucking around at the shell level, trying to specify how to manipulate that and doing pSQL calls to manipulate the database state to instantiate a database. and manipulate users, alter user with password, things like that. That just is like the wrong level for a lot of these kinds of problems as far as I'm concerned. There are certain things you have to do at that level because they're so domain specific in what you're doing. You need to optimize how much memory you're allocating to the Postgres connection pool based upon the size of the EC2 image you're running on. Is this a high mem instance or low? There's certain just low-level things that you have to do there that you have to pretty much script that are less declarative, I think. Creating the declarative version would be so much extra work, there's no win in the end. I think it's one of the advantages of the declarative thing is you can read it too. You can show it to somebody who's not an expert in it, who doesn't know that much about Fabric, say, or Postgres. Say, oh, database user, yes, roster, I see that. You're creating a database user, I kind of grok that. So there's some improved readability possibly. But, yeah.
So this file we're looking at here,
Yes.
it makes it evident that Chef is serving as the bridge between your centralized configuration and Apache. So have there been any moves by applications to say, I don't want Chef to bridge this, I just want to fuse my functionality with Chef's? Sort of like you just pass the application a hash, and it goes, oh, I know how to read this hash.
Not that I'm aware of. I think probably one of the reasons that Chef and Fabric and Puppet and these things exist is these communities, Apache and Postgres and stuff, are so disparate that the hope of all of them agreeing on some common mechanism to configure them is probably a bit of a pipe dream. So Chef is glue, basically, across all of these things to give you some common tools to force them into the states you want. On Unix systems, configuration 99.9% of the time is done with a text file. So templates and file objects or resources get you pretty far down that path. I don't know if that's an answer, but my 2 cents. Sure. Yes?
Let me get this straight. There is no more Hornblower's restaurant on the building?
There is none. We sold off the kitchen in the fall of last year.
I couldn't get over that.
If anybody wants to come see it, let me know. We are moving back there. Actually, the trucks are there right now. We packed up we've been in Burke Lakefront for the last almost year on the second floor as the boat's been renovated. Windows were cut out, new steel and windows and magic.
Amazing.
Yeah, come visit us. I have a couple T-shirts. I don't know how to give them away. I'll put them up here. I only brought 2. I wasn't getting several fastest. So thanks again. If anybody's interested in co-ops or internships or anything, please let me know.